All right. Hello, everybody. Hello, hello, hello. So good to see you today. I'm sorry I missed you at school. I had a meeting off site, so that's why I was gone. Excuse me. But it is important that we still review for your tests. Now, this is the official review sheet that people got. Oh, I just realized I'm not even using my headset. So hold on 1 second. Perfect. Let's see. Okay. There we go. Okay, I'm actually using Freddie's headset. Don't tell him, he'll probably be upset. Okay, so here we go. It looks like it's working. Basically, what I want to cover is an overview of what we need to know for the assessment. I'm going to mute this tab. Okay, because I keep hearing myself in my head, and it is annoying. So I'm going to mute my, nope, don't do that. I'm going to mute myself. Perfect. Okay, so tomorrow, Thursday, August 30th, is your test for strategies. That test is going to be open note. So you will be able to utilize this review sheet. You will be able to utilize your packet for that test. I'm in the process of creating it now for you to take on assessment. Now, Friday is the real thing. And that real test, you can have nothing to help you. So remember what the growth mindset is, taking incremental steps for us to hit success. And that's what it is about. So we're going to just dive right into it. Chat should be open. Let me just say hi all to make sure that it is. Feel free to ask questions, say hi, give a little shout out. I would love to see that you are here. And let's get started. So the first thing is draw all of the lines of symmetry for each figure. Now, let's see. This first figure is a trapezoid. It happens to be an isosceles trapezoid. We can tell because if we look here and here, it's pretty evident that they're about the same size. So we can just make that estimate. So I know the answer was on the board, but this would have, why am I using the mouse? This would have one line of symmetry, and that one line would cut right down the middle. The reason why it's not going across is these points jet out a little bit more. Remember when we talk lines of symmetry, it's where can we slice and dice an object? Oh, where can we slice and dice an object for it to fold in half on top of each other? Lauren, I mean, I can't have favorites, but I will give you a shout out and be like, whoop, whoop. There you go, Lauren. Next, we have this right triangle. This also appears to be an isosceles right triangle. We can notice that here, hey, Brichene, here and here are about the same size. So because of that, we can cut on the diagonal. So this, well, that's horrible. This would be the line of symmetry for that object. This next one is kind of tricky. There's actually 8 lines of symmetry. And unfortunately, I can't spin this document to show you, but I can give you a kind of heads up. Whenever we come to regular pentagons, or I'm sorry, regular polygons, usually speaking, we can cut through points and we can cut through sides. So this one might have been very evident to you, and this one might have been very evident. But we also could do the diagonals of the sides. And so right there, that's 4 lines of symmetry. Then it gets even trickier because we can do through the vertices or through the points. So I can go through this point, pretending that's a straight line. I can take this one over here. So really, we're talking about 8 possible lines of symmetry. 4 of them are bisecting the sides, and the other 4 of them are bisecting the vertices. This right here is a rhombus. We know it's a rhombus because all the sides are the same. It's clearly not a square because there's no right angles. So because there's not a square, we cannot have horizontal and vertical. What we can have are diagonal lines of symmetry. So this one would be right here, and this one would be here. Beep, 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 boom. Okay. The arrow, I think, is rather self-explanatory. You're going to go right through the middle. Obviously, you couldn't do it in half because of these lovely points. Someone had said, can I go like this and like do the curve? Truly, you can't do the curve. You're going to have to just do the straight line down for this one. Beep, boom. This is an isosceles triangle. So because it's an isosceles triangle, again, it's only once down the middle. If it was an equilateral triangle such that all the sides had the same measure, then you could do it differently. You could have it this way, but then you could also have it through each of the vertices. Okay. This one was tricky. I got this wrong the first time I did this one because I didn't pay attention to these circles. So I originally did, now it looks like a truck. I think most of us can agree it has the horizontal and vertical. I incorrectly did the diagonal. And that won't match up because it's rectangular. So with the corners missing, the fact that it's still a rectangle, you can't do the diagonal. So the diagonal is a on that one. Let's see, the heart. The heart is just straight down the middle, broken heart. And this is on the diagonal this way and also in half. So lines of symmetry, rather cut and dry. Your whole test is going to be done on lines, so you're not going to be really drawing lines of symmetry. If anything, you'd have to identify them on the test. Next, this is like one of my favorite parts. What are all the degrees of rotational symmetry for each of the polygons shown below? So I'm going to trash this, scroll it. Remember that if we see something that is a regular polygon and all we need to do then is we do 360 degrees divided by n, where n equals the number of sides. This trick only works if it is a regular polygon. It would have to tell you that it's a regular polygon, or it would have to be evident that all the sides are the same. Now, real quick, I'm going to scroll here and show you this one. Here, this rhombus, all the sides are the same, but the angles are not the same. They're not equal angular. So because of that, it doesn't work. You can't do 360 divided by 4. But for these shapes, you can do that because it's identifying them as regular polygons. So then all we're going to do is we're going to take our 360 and we're going to divide, in this case, by 5, which I don't feel like doing in my head right now. So we are going to do 360 divided by 5 is 72. Now, here's where some kids have been missing it. It's not just 72. It's every 72 degrees. So we've got 72. Then it's got 72 plus 72. Hey, Nevaeh, is 144. 144 plus 72 is 216. 216 plus 72 is 288. And then if we do plus 72 one more time, that's where we're going to get our 360, which we don't count. So the regular polygon is divide first and then just keep adding. Boom, shada boom, shada boom. Chicka boom, chicka boom. Oops. Next, 360. This shape has 6 sides. It's a hentagon. So we know hentagon. It's a hexagon. So we know that what we're going to do is every 60 degrees, it's going to map on itself. Key, anytime we see map on itself, 95% of the time it's rotational symmetry. So we've got 60. 60 plus 60 is 120. 120 plus 60 is 180. 180 plus 60 is 240. 240 plus 60 is 300. 300 plus 60 is 360. So we know that we don't count that. And those are when I have all the degrees for rotational symmetry for a hexagon. You don't have to memorize this. Just memorize the process. You don't have to memorize the numbers, just the process. If it is a regular polygon, if all the sides and all the angles are the same, divide by the number of sides. Here we've got it divided by 8. So I've got 360 divided by 8. That's 45. Hey, Alyssa. So I've got 45. Plus 45 is 90. Plus 45 is 135. Plus 45 is 180. Plus 45 is 225. 270. I feel a sneeze coming on. And 315. I would say that that is written by Lauren, not me. Because she can't even say Dr. Ihrig. I mean, let's face it. Just kidding. All right, isometry. This is going to be on your test. I typed the question today. And isometry is anything that the major beautiful words that you must know till you get to college is that isometries preserve distance. And what does that mean? There's only 3 of the 4 transformations preserve distance. Those 3 are translation, rotation, and reflection. Okay, that's it. That's it. Translation, rotation, reflection. That's the only ones. All right, I'm going to stop that part there. Let's trash it. Bing. And go on to the next questions. Why are you making it super big? Okay. Parallelogram has vertices 0, 0, 0, 6, 4, 4, and 4, negative 2. Oh, I had to type that. Let's be realistic. Okay, parallelogram has these points. They already mapped it for us. That's beautiful. I can't remember if I did that for you on the real test or not. Which transformation maps the parallelogram onto itself? So it's got rotation as one of them. Remember, maps to itself. It's almost always going to be rotation. Okay, so what we're going to do first is clearly I can't talk and type at the same time. So now we're going to do is let's check it. So first things first, a reflection over x equals 2. Remember, here's our x-axis. Here's our 2. So this is the line. They drew it for you already. So if we fold it on that line, what would happen is this point would be over here. So because that point would be over here, that's a horrible parallelogram. It can't be A because that point would match up. It would not match up, rather. So it can't be A. B says a reflection of y equals 2. Here's y equals 2. They drew it for you. However, if we flip it this way, this point would be up here. So it would look like this. Clearly, those don't match up, so it's not choice B. Okay, the next one says rotating it 180 degrees about 0.22. Here's 0.22. So if we spun it, it would map up to each other. So it is actually choice C. The reason why it's not choice D is if it was choice D, it would actually look like, let's see, it would look like this. That's a horrible parallelogram. But if it was 180 degrees about the origin, it would look like the orange one. So it's not the orange one either. Next. Given the coordinates, let me know if I'm going too fast. Given the coordinates of S and T, what would be the coordinates of the reflection across the x-axis? That is why I pulled this lovely stuff up for you. I highly recommend, we're going to meet in the classroom before we go to the computer lab. I highly recommend that you bring your cards to school tomorrow if they're not at school, because you can use these cards tomorrow. This says a reflection across the x-axis. Because it says across the x-axis, I'm going to find my rule. The rule for reflecting across the x-axis is all this fancy-dancy stuff, or keep the x and do the opposite of y. I taught you in class to put your hand over it. Hey, Destiny. So because it says the x-axis, I'm going to just only pick ones. It says keep the x. So that means I have to keep -3 and -5. They stay the same. So I'm going to show you at the end of the video how to get these notes up. The notes that I'm showing you that I think are the most important are the notes that we did on August 24th. So that's what I recommend looking for, is the August 24th notes. are super uber important. And that's what have these formulas on it. So if you have the notes, these rules from August 24th, that would be the best to do. Next, we're going to go down. You guys are great. So now we're going to reflect on the x-axis. So we keep the x, do the opposite of y. So I'm going to just eliminate the ones that don't let me keep the x. This says -3, -3. So we're good. That keeps it so far. This says -5. This says -5. So this is a possibility. Okay, we'll put a little half face. We don't know. This one says +3 and +5. So we know that it's wrong. We know that it's wrong because when we reflect on the x, we keep the x. Remember, x, x. When we do the y, we keep the y. So reflecting on the x, we keep the x. Here we've got 2 and 3. That means they switched it. So it can't be that one. Here we've got +3, +5. So they switched it again. So it can't be that one. So this is the one that it has to be. And it has to be that one because we keep the x and flip the y. Next, we're going to do identify the transformation, rotate something 100. Oh, we have to identify it. Well, if we can tell, this is W is pointed down here and it's pointed down here. So because it's pointed down in both the image and the original pre-image, this is the pre and this is the image, we know that it has to be a translation because it's keeping the same direction. So we know it can't be that and it can't be that. If it was the reflection, if it was a rotation of 180, it would look something like that. If it was a reflection on the x-axis, then it would look like that. So that's why it can't be A or B. So now it's testing you. Do you know what to do and what is the image and the pre-image? This is probably the most important thing to remember. The image is always the one with the little lines. The pre-image, what comes first, has 0 lines. So it's like x to the 0, but we just don't write the 0. It's just x. Okay, so this is the pre. So we're going from this shape to this shape. The people who got things wrong on the quiz, they mixed up which came first. The one that comes first is always the one without the little lines. So how did it happen? Well, this came from it. This x moved to the left and it moved up. So it's got to be choice D. Please, please, please figure out please figure out what the difference is between the image and pre-image. If you don't know that, it's going to be an issue for you. A figure is translated to 3 units left and 3 units up. This question is on both tests. Which translation will move? Tomorrow's is open quiz. Which one will move it back to its original position? And honestly, I think I did this wrong on the review sheet on the board because I don't think I did the original position. So this is saying after this happens, how do we go back to what we started from? So if what we did was we moved left 3 and up 2, we actually have to do the opposite to get it back to its original position. So instead of going left 3, we actually will have to go right 3 and down 2 because that's how we get back. So it's like if I take 5 steps forward, how do I get back to where I started? I have to take 5 steps back. If I move to the left, how do I need to do it? Move it to the right. Move to the left, to the right, to the right. That's what we're doing. We're doing the opposite. Whenever you see original position, I want you to think, oh, opposite. Oh, the original position tells me, oh, I need to do the opposite. Okay, so right, if we think of right, here's our left is negative. Our right is positive. Hopefully you know up is positive and down is negative. So which one is right 3? Well, right is positive. So we know we have to go right 3. So it can't be A or C. Then we go down 2. Which one is down? The negative. I'm pretty sure I did that wrong on the paper because I did that late last night when I turned the stuff in. So that is the correct one. Back to the original position means you're going to do the opposite. Opposite to original position. Opposite. In the graph below, figure WXY is the image of figure, or W prime, X prime, Y prime. It's the image of what under a rotation of what. So basically here, this is the one that has no letters. So this is the one that we're starting with. This is the one we're going to. So what happened from here to here? We know that something happened. All of these say something with clockwise, so we know it's a rotation. We know that every time it jumps a quadrant, it always moves 90 degrees. So let's take a look. 90 degrees counterclockwise about the origin is actually the correct part. But let's look at why the other ones are not correct. But that's right. 90 degrees counterclockwise. This is counterclockwise. And we know that that's counterclockwise because we know a clock has 12 o'clock here, 3 o'clock here, 6 o'clock here, and 9 o'clock. So we know that this is clockwise. So the other way with the pink was counterclockwise. So the answer is choice A, but let's look at the other ones. Get away, get away. Next, the next one says clockwise about the origin. So if it was clockwise, then our shape would be up here. And it's not, so it can't be that one. 270 degrees counterclockwise about the origin. So this is counterclockwise. 1, 2, 3. It would put the shape over here, so that's why it can't be choice C. And 180 degrees would, of course, just put it opposite right here. That's why it's not choice D. Goodbye, D. Nice to see you. Trash can. Scroll. Given the coordinates, blah, 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 what would be the coordinates after reflection across x equals -1? All right, I'm going to pull this stuff over right here, and let's use this graph paper real quick. I'll put it right here. So our point is 1, 3. So over 1 up 3 is our first point. Pen tool, pen tool, pen tool. 1, 3. Our next point is 4, 2. So here's our points, 1, 3, 4, 2. And it says the line x equals -1. So remember, when it says x equals -1, we look for the x-axis, we circle the -1, and then it has to go right through that point. So that's where we're reflecting against. Now it's just a matter of counting. Whenever we do reflections, all we do is count. We make straight lines. It's a straight vertical line of reflection, so we're going to count horizontally. 1, 2, 1, 2. Here's my new line. 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait. 1, 2, 3, 4. Yep, 5. And so here's our new one. So our points are -3, +3, and -6, +2. Let's see, are there one of those things? -3, +3, -6, +2. Choice B for boy. B for boy, B for bingo, B for bananas. Because math makes me bananas. All right, next. Using the diagram below, AB is translated so that x, y, blah, 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 x minus 2, y plus 1. Find the coordinates of the endpoints of the image. This is when I like to, math hack it. Why make things difficult? This tells you x minus 2. So all I'm going to do is, here's my x. Go backwards 2. Boop, boop, boom. Then it says y plus 1. So I got to go up 1. So I already know my first point is 1, 3. So it's got to be choice D. But let's just do the other point. Next point. Plus, where's the next point? Here we go. Back 2. Boom. Up 1. Boom. 3, 7. So that's how it works. Hope you get a lot of translations. I don't remember what's on the test, but that would be great. Okay, next. Let's see. Let's do that. I keep having the clock in my chin. All right, next. Not that that's any better. The rule for, there we go. The rule for this transformation is question mark. Again, this is checking. Do you know the preimage versus the image? So this is the preimage. We know that this is the preimage because there are no little lines. So that means this comes first, this comes second. Which came first, the chicken or the egg? Oh, I don't know. But which came first, the preimage or the image? Always the preimage. So what happened? Well, here to here we moved left. We also moved in a negative direction. So I'm not even going to count. I'm just going to cross off anything that says I'm moving in a positive direction. Then from this point here to this point here, what did we do? We moved up. The only one that is up is choice C. True or false? I apologize. Clearly, I still have my cough. Okay, next. Highlighter. Okay. Hey, Bree Shanae. All right, next we're going to do A and A prime. So if I connect these points, it's A to A prime, B to B prime. Remember, anytime you have translations, you always create parallel lines. That's how you know it's a translation. So this is true. That makes sense that those two lines are parallel. The same goes for this next one. If you have C to C prime is going to be parallel to B prime. AC is this line and this line. These lines will always be parallel. If it's a reflection or rotation, they won't be, but because it's a translation, they will be. Next. Oops. All these were trues. Let's just do that one more time. T, T, T. Now we're talking about congruence. This is congruent to this. We know that that's the truth. We know it's the truth because it's an isometry, and isometry preserves distance for what matches up. So AB matches with A prime, B prime. So that matches, so it's congruent. Okay. The length of A prime and B prime. That is also always, because it's a translation, going to be congruent because we're moving everything the same distance. So that's why it's definitely congruent. Next, A to A prime is parallel to B to C prime. Well, I hope you can see that that is not going to be the case. They are going to intersect, so that one is incorrect. Honestly, Alyssa, I can't promise that I'm going to be there early in the morning tomorrow. I think the earliest I could maybe meet you would be 6:30. So I can write that down. Okay. Next, we have AC to CB prime. So here's AC, and we're matching it to the length of C to B prime. I mean, even right there, you can tell that they intersect. So that's false. Okay. Next, figure CDEFGH is reflected. Decide whether each statement is true or false. G, the length of GG is parallel to HH. We know that that's true. That's pretty much what a reflection does. However, they are not congruent. It's very obvious that this part here is smaller than this part. So this part is false. And the last part is also going to be true because, let me erase that. FF is this line here. FF is always, remember, it always forms right angles. So this part is also true. Mm-hmm. Okay, next. If you connect D to D prime, the midpoint will be on AB. Yep, that's also true. Because whenever we do reflections, we know that we count distance. So this part has to be equal to this part. So this is true. I don't know if I did that yesterday or not. Next, graph the figure -1, -1. Let me just erase this and start higher. Okay. Graph the figure -1, -1. Right there. -5, -1. -5, -3. -3, -3. So it looks something like this, give or take. And rotate the figure. All right, dude, rotate. What are we going to use? Let's go to our cards. Next, let's go to our cards down here. Rotate 180 degrees. What's the rule? Opposite X, opposite Y. Nothing changes. We don't do any flip-flops. Because it's 180, technically we do a flip for 90, but then when we do a flip back, the actually stays the same. The only thing we have to worry about is just flipping the signs. So this -1, -1 becomes +1, +1. -5, -1 becomes +5, +1. 5, +3, 3, +3. Everything just becomes positive. That's it. Okay. Please use your cards tomorrow. Next, draw a line segment with points -6, +3, -5, -2. Here's my line segment. It says that it's translated over this rule and then it's reflected. So, and it says write the coordinates of each image. We drew it. I would just kind of be like, let's just do it in our brains. We have our -6 and we have our 3, and then we have our -5 and our -2. The first thing it tells us to do is it says add 5 to the x's. We know that because it's right here. And we know it says add 2 to the y's. So we know that it's right there. So all we're going to do is just add it up. -6 plus 5 is -1. 3 plus 2 is 5. So this is our first point. -1, +5. When we do it down here, -5 plus 5 is 0. -2 plus 2 is 0. Done. So we've done the translation. We went over 5, up to, done. Now it says y equals x. So what is our rule for y equals x? Let's go back to our little note cards. Reflecting over y equals x is right here. What's the quick rule? Flip the x and y. So let's just flip the x and y. Here's -1, 5. Flip the x and y. Now it's going to be 5, -1. All we did was flip-flop them. And then 0 flip-flopped is just 0. So you could, if you wanted to, you could have drawn the shape like this, and then you could have done the reflection. That was awful. Then you could have done this reflection here. You could definitely have done that because here's the line y equals negative or y equals x. I would have just in this case do exactly what I did. I would have just used the tricks because for me, it's easier. But if you do a better job graphing, then you definitely can just go ahead and graph it. Explain what happens to the coordinates of a figure when it's reflected across the x-axis. Let's look at our note cards. Reflection across the x-axis. How beautiful is that? What do? We keep the x and we do the opposite of y. What do we do when it's the y-axis? Let's go back to our rule. Our rule says, come here, where are you going? I guess I just have to write it over again. Our rule says whenever we reflect across the y, it's the opposite of x and we keep the y. So in this case, it's keep x, op y. For this one, it's op x, keep y. It says rotate the degree this figure 90 degrees about the origin. again, for me, I would prefer to do the numbers because it's way easier. So I know that I've got UVWX. Okay, so I've got VWX as my order. Of course, I do my alphabet. So here our V is -3, 5. Our W is -1, -3. And our X is -1, -5. Well, if we're going 90 degrees counterclockwise, that means we're going to go this way. So everything's going to be in quadrant 4. What do we know about quadrant 4? We know our X's are positive and our Y's are negative. So you can just put in the positive and negatives if you want. Usually I show you the switch first, but you can also do it that way. And then every 90 degrees we flip. So if we have 3, 5, 5, 3, 5, 3, 1, 3, flip, 3, 1. 1, 5, flip, 5, 1. Now we can just graph it. 5, -3 is right here. 3, -1 is right here. 5, -1 is right here. And so here is our little shape reflected about the origin, 90 degrees. This next one says rotate the figure counterclockwise about the point. This is probably going to be the most challenging. I believe there's 30 questions on the tests. Okay. So I think there's one question that you have to rotate around a point. Let's see what I can do to try to make it a little bit higher on the screen. See if I can do that. Okay. So what we're going to do is we have our point, -1, -3. Oh, they're so generous. That's perfect. That's where W is. So we know the first point is just going to be W. It says 90 degrees counterclockwise. So this here, we always form right angles. This point right here is just going to go right there. So this is 2 this way. So now we're going to go boop, 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 2 this way. This is our new X point. So we've got our W is going to stay the same. -1, -3. Yep, that's right. Our new X point is going to be 1, -3. And our new Y, here we've got to go down 2, over 2 to here. So now we're going to go down 2, over 2 to here. And this is our new V. So this is how I math hack how to do this problem. And it makes sense because look at it's part of the pinwheel. So that's how I do it. Let me show you another way to do it, which is like the official way to do it. If you want, you can just turn this into an X and Y axis. Basically, what we're going to do is we're going to reflect each shape. So this right here would be reflected to this. And then, oh no, that's for 180. Don't listen to me, I was lying. Then what we're going to do is switch the coordinates from here. So this point stays the same because it's at the origin. This point from this new axis that we made is 0, -2. So we have to flip-flop it. So now it's going to be 2, 0. So that's how we get that point, which 2, 0 in real life is the 1, -3. Here's our real axis. That's 1, -3. This point in pretend is -2, 2. So when we flip it, it's still 2, 2. So over 2, down 2. And here's our other point. So that's the other way. You can draw the fake X and Y axes. Don't stress about this problem. It's not a lot of points. Okay, so that is pretty much it for here. What I am going to do next is 2 things. So don't leave me. It's important that you see this. It's not important that you watch Freddie Prince's videos. These are Freddie Prince's videos. I want to go here and just go over what is in our page, our e-class page. So what I have for you is slowly loading. Announcements, the most important stuff is always going to be front and center. So for example, the YouTube live video that you have tests coming up. Here's the review sheet. DMI is Dr. Michelle Ihrig and the link. Here I put all notes added to content. I did this because some people couldn't find it. I couldn't figure out how to link you right to the folder, but if you click this, then you're going to get linked to one of our notes pages. And then from that notes page, you can now click Let me make it bigger so it works. You can now click Unit 1 Geometry, and that's one way that you can get to the geometry notes is by clicking that link first, then clicking Unit 1 Geometry. The other way that you can get to it is just clicking Content, and when you click on Content, you're going to be taken right to our page. So here's our table of contents. First week stuff is really the stuff related to the growth mindset. Unit 1 geometry is what we've been doing. So these are all the notes that we've done. A little trick. If you click on it, you can also navigate. You can scroll inside your computer. But what I like is this feature that you can just hit the right arrow key and it just takes you to the next set of notes. So that is another tool that you can use. And then the last thing I want to show you is I think is very important. And I will also put it in this. I haven't uploaded it. Let me know. Let me do it right now. The vocabulary cards is really important to have also. And the notes that you need are the ones from, I think, the 24th. So let me just add that up for you right now. Really, I have a whole lot of stuff on my computer. So this I just added into the vocabulary section. So if you're missing vocabulary words, this is where you can find them right here. Let's see if it lets me change the name. It might not. Oh, it does. So Unit 1, Transformation Rules. So I highly recommend that you pay attention to these documents because they're going to be the ones that are going to help you the most. The transformation ones and the plane are things like what is a rotation, what are transformations, and that's what these are. However, the rules are what you're really going to need to know. So I recommend doing that. Lastly, please make sure you know these. I don't know how many times I'm going to have to say that, but I mean it. If you have a translation, remember that that pretty much just moves. So if I have this box right here, a translation just moves that box somewhere else. Okay, and we count how does it move. Whenever we do translations, we always create parallel lines. Okay, so add and subtract X and Y. Done. Next. Reflection on the x-axis. If we have a shape like this, get our good old pink box again. This is my x-axis. I know it's my x-axis because oftentimes there's an x and y. All you do is count. Boop, 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 boop. That's 2 each. So that means I got to go 2 more. Boop, 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 here. And then if I do the other ones, that's the x. If it's the y-axis, same idea. Here's my line. Here's my box. The y-axis is this one, so I'm going to count. 2, 2, and then I can draw my box. Okay. Also, notice the y stayed the same. This is y equals 3. This is y equals 3. This is y equals 1. That's y equals 1. The only thing that changes is the x value. Let's see what else. Reflection over y equals x. You do need to know this. Y equals x is the line that goes diagonal through. So all we do is we flip x and y. If this is our box is at -2, +1. So you can flip x and y. Or you can do the counting method. Because it's a diagonal line, we count diagonally. 1.5, 1.5. And then you can draw the box. Okay, this one, 2.5, 2.5. Every time you're going to get these parallel lines. It's pretty much just what the rule is. Most people screwed this next one up down here, y equals -x. Just make sure for y equals -x, remember that we're going down diagonally. So not only do we flip, we also do the opposite. So if this is our shape, we're going this way. So that's where our new shape is going to be. You're going to flip the signs. Flip them and switch the signs. I would say those are the big ones you need to know. Rotations you should know, but the main thing is this. Every time you do a rotation, make sure that you flip the X and Y and just know the signs of the quadrant. One more reminder, this is positive, positive. Like this. This is negative, positive, negative, negative, positive, negative. Okay, and it makes sense. These numbers are positive, so the Y values have to be positive. Okay, all of these numbers are negative, so the X values have to be negative. So just kind of matches up. All right, I think I'm going to stop there. Let me see if you guys had any questions that I missed. I will be at school. I'll work very hard to get there by 6:30 tomorrow morning. So if you want to join my dom, Alyssa, and myself, you're welcome to do so. And I am going to just end it right there. You guys have been awesome. Love you. I am not going to do another one tomorrow night because I'll be covering the exact same stuff. So your main thing with if you're going to have a growth mindset is to use these notes tomorrow. Okay. Bye, guys. See you later. Ciao. Then we're going to go here.